In this session, we are going to study about the distributed databases. Okay. So before I begin telling you about what is a distributed database, let's first understand what is a distributed computing system. Okay. Distributed computing system. So distributed computing system is a collection of processing elements, okay, which are interconnected by a network, and they together coordinate to perform a specific task. So I say, let's suppose this is my network. Okay, let me just write it as network. So my distributing computing system is a collection of processing elements. Okay, so these are my processing elements. Okay, and these processing elements are These processing elements are normally heterogeneous. Okay, I would just write heterogeneous processing elements. Okay, so let me just call it as P1, P2, P3 and so on. Okay, oftentimes if it is a homogeneous system, then probably it is going to be a parallel computing system. Okay, the distinction between a parallel and a distributed computing system is that more often than not, in a distributed processing system we have heterogeneous processing elements. Okay, and these processing elements coordinate to perform a common task. So that is the concept of a distributed computing system. Okay, now let's see what is a distributed database. Okay, I would just write over here distributed database. A distributed database is a collection of logically related databases, okay, distributed over a network. Okay, distributed over a network. So we have a distributed computing system. Okay, but the thing is, along with the processing elements, I also have a database over here. Okay, so this is my database which is connected to my processing element. Okay, so this is what I call a distributed database system. Okay, let's just call it as DB2, DB3 and DB1. Okay, what I'm saying is it is a logically related collection of databases. Hence, all these databases are related in some manner. Only then I can call it as a distributed database. Okay, and this is what? This is my network. Distributed over a network, right? So this is a distributed database, and hence from this definition we can arrive at the definition of a distributed database management system. Okay, distributed database management system. What is this? It is a system that manages a distributed database. Okay, system managing a distributed database and making this distribution transparent. So it makes the distribution transparent. What is the meaning of this phrase, making a distribution transparent? It means that, let's suppose here I have a person, okay, and he makes a query by saying that my distributed database management system makes the distribution transparent. Then it means that this guy can make a query without being aware that my database is distributed. Okay, so I can make a query as if there is a centralized database. Okay, I am totally not aware that where my tables lie. There may be some tables at this particular location, there may be some other tables at this particular location that I have to reference for my query. All this is managed by the distributed database management system. Okay, the user is totally unaware as to what is happening behind the scenes. Okay, so let's suppose I have here departments table. Okay, this database, or let's do it as like this DB contains the department table. Okay, and this DB, let's suppose, contains the employee table. Okay, and here I make a query, find employees working in research. Okay, so my user actually doesn't know that employee table is not at this particular location, although user is at P1 but employee table is at P3. Okay, so my distributed database system is going to convert this query into two sub queries, where first I am going to fetch tuples from department table, then I am going to fetch tuples from employee table, and I'll take a join probably at this site. Okay, and I'll return the result to my user. All this is done so as to make the distribution transparent. Okay, now let's look at what are the advantages that my distributed database provides. Okay, advantages of distributed databases. Okay, I'll write it as DDB. Okay, my first advantage is that it provides transparency. Okay, we've already seen what is the concept of transparency when I talked about making the distribution transparent. Okay, let's understand what are the different notions of transparencies that we have. Okay, first we have network transparency. We've already talked about what this is, right? It is making the distribution transparent across the network. Okay, there are two facets to network transparency. One is location transparency. Okay, that's about you do not have to care about where your relation or part of the database is located. Okay, you are here at P1 and you are making a query that accesses databases from site P1 and from site P3 also. So you do not care about where databases or elements of databases are located. That's about location transparency. You can execute any command from anywhere, okay? You can execute any query from anywhere using the same command, okay? That's about location transparency. I'll write it as any query from anywhere using same command, okay? That's the concept of my location transparency. And the next facet within my network transparency is the concept of naming transparency. Okay. Naming transparency indicates that once I have given a name to that object, okay, once I have referred to a particular object, my system is easily able to distinguish that object from amongst various objects and is able to access that object. Okay, so it is about unambiguous accesses, okay, unambiguous accesses once name has been specified, okay. Just like if you type Amazon.com, right, you really don't have to worry about where the server is located. The system is going to unambiguously take you to the server where Amazon.com is hosted, okay. So that is the concept of naming transparency, right. Now the next transparency that we have over here is, I would just extend the line, okay, so that I maintain the order. Okay, so the next transparency is replication transparency. Okay, my replication transparency is about maintaining the replication without user knowing anything about it, okay. So let's suppose I have an employee table and that employee table is replicated across two sites, okay. It is also present at site 1 and the copy is also present at site 2. The concept of replication is, if I make some modification in employee table at site 1, the same changes are reflected to site 2, okay. So this reflection is taken care of by the system, okay. User must not worry about it, okay. He shouldn't even know that employee table is replicated, okay. So that is the concept of my replication transparency, okay. So I'll just copy this, okay, and move it over here so that when you refer this back, you understand what is my replication transparency, okay. Just understand the difference between replication and duplication. Replication, all the copies have to agree to each other, okay. In duplication, it might not be true, right. I would say employee table is replicated at site 1 and site 2, okay. and then changes in site 1 is reflected on site 2. Similarly, changes in site 2 is reflected on site 1. That was the concept of replication transparency. Next type of transparency is fragmentation transparency. Okay, fragmentation transparency. The concept in fragmentation transparency is, I have a employee table. Okay, let's suppose. So here what I can do is, I can keep, let's suppose this is my employee table, I can keep half of this at site 1. Okay, let's suppose I am keeping the lower half at site 1, and I can keep the upper half at site 2. Okay, so this indicates that I have fragmented my employee table. Let's call this as upper half, lower half. Here I have upper half at site 1, here I have lower half at site 2. Okay, so what I'm basically doing, I am fragmenting my table into 2 or more fragments, and all these fragments are stored at different locations. Okay, so this is the concept of fragmentation. Actually, this particular type of fragmentation is known as horizontal fragmentation. Okay, I would just write it as HJNTL, that is horizontal fragmentation. Similarly, you can have a vertical fragmentation. So here what you do, instead of let's just write it nicely. Okay, I'll say vertical. Okay, and I have this coming right here. Okay, there are 2 types of fragmentation. One is horizontal and the other is vertical. Okay, so in vertical fragmentation, what we can have is, you have an employee table. It is like this. Okay, and what you do is, let's suppose I call this a right half, I call this a left half. Okay, so I can store my right half of the employee table at site 1, and I can store the left half of my employee table at site 2. Okay, so I am vertically fragmenting my employee relation. That is the concept of vertical fragmentation. The transparency aspect here is, the user should not know that your relation is fragmented across different sites. Okay, so he should be unaware, and you should manage the modifications over here. Okay, so if my user says that do something, modify some tuple in my employee table, then database should realize that that tuple was in upper half, so that access now has to be made via site 1. Okay, so that is about my fragmentation transparency. So that is, first advantage is that it provides me transparencies which are of these types that I've just talked about right now. Now next advantage is, it gives me increased, let's type it over here, increased reliability and availability. Reliability and availability. Okay, what is reliability? Let's look at this. Reliability is the probability that my system is working at a specific point in time. Okay, so I'll say, let me just copy this and I'll just move it down. It says system is working at a particular point in time. Okay, the keyword over here is at a particular instant in time, while my availability says or determines the probability that my system is working continuously during a particular time interval. Okay, so system is working continuously during a particular time interval. Okay, time interval. So the keyword over here is I am talking about the time interval in availability, while I am talking about just a point in reliability. How my reliability and availability is increased? It is increased because my distribution in database is across many sites. So let's suppose my P2 goes down, then I can still perform queries on database 1 and database 3 because they are working fine. My entire system has not gone down due to going down of the site at P2. Okay, hence my availability and reliability is improved. Okay, and the next advantage now is improved performance. Okay, improved performance. Okay, how the performance is improved, I'll just explain you by telling you how a centralized database system looks like. Okay, in a centralized database system, I have a, let's suppose this is my network. Okay, and this is my, I call this a centralized database. Okay, centralized database, and I have other, let's suppose I have other sites from which I am making accesses. Okay, so this is site 1, this is site 2, this is site 3, this is site 4, and this guy is site 5, and this whole thing is my network. Okay, so what happens if S1 wants to make a query? That query goes from the network into the centralized DB. Similarly, S4 goes to the centralized DB, S3 goes to the centralized DB. So every query is being diverted to centralized DB. Hence, this server over here becomes a bottleneck. Okay, because all the requests are coming to this server. Okay, while in my distributed system, as you can see, if I am making a query at P1 and all the database elements are present at P1 itself, then I do not have to transfer this query request to other sites. Okay, therefore I can quickly give my result to the user at P1. Similarly, if there are many elements being accessed in the query located at different locations, then what's going to happen is I'm just going to make a request at P1, P2 and P3, and now P1, P2 and P3 are going to collaborate and parallelly find my result. Okay, so that is the concept of parallelization in a distributed based system. Okay, my results are faster because all these locations or sites are working in tandem to execute my query. Okay, therefore I say my performance is improved. And the final advantage is that a distributed system is easier to expand. Okay. When you are talking in terms of a centralized system, then there is a limit to how many processors you can add over here or how many disk systems you can add over here. However, in a distributed system, you can easily add many number of processors at a particular site, and if let's suppose a limit is reached where you cannot add more processors to a particular site, you can add more number of sites. Okay, so it can be add more locations, or you can also add more processors at each site. Processors per site. Okay, so I say it is easier to expand. Okay, now we are going to look at what are the additional functions that a distributed database management system provides. Okay, obviously it is going to provide the functions or responsibilities that a normal database management system is going to provide, but there are some specialized functions that a distributed database management has to take care of. Okay, so first function is keeping track of data. Okay, since in a distributed system your data is dispersed across different sites, you have to know which data element resides at which site. Okay, next function is distributed query processing. What is this? Now the responsibility over here is you have to divide your query into sub-queries so that each can be executed at a different site. Okay, so you have to do something like this. Okay, why? Because I am querying at P1 regarding information from department table which is at P1 and employee table which is at P3. Therefore, I have to create a subquery so that it can fetch results from P3 and then merge it with the results from P1 so that my final output can be displayed at P1 to the user. Okay, so that's the concept of distributed query processing. Next function is distributed transaction management. Okay, again you have to make your transaction such that it can be executed at different locations simultaneously. Okay, you have to make the synchronization between different threads or different sub transactions which are being executed at different locations, right? Next is replicated data management. We've already seen the concept of replication, right? So when I told you in replications I have to ensure that any changes over here are reflected down to the other replicated site. So this reflection of changes I have to perform, or this reflection of changes has to be performed by my database management software, replicated database management. Okay, next is distributed data recovery. Okay, now I have to ensure that system does not get affected if only one site fails, and I have to recover gracefully from the failure of a particular site. Similarly, if a particular link in a network fails, then I have to recover from that as well. So there are two aspects. One is link failure and other is site failure. Okay, you have to gracefully recover from both of these failures. Okay. Next is security. Obviously only the right person with right access should be able to access your data. Since you have so many locations, you have to ensure that security is properly managed. This may not happen that a person comes at P1 and P1 rejects his request saying improper access privileges, but he goes to P3 and that request is accepted. Okay, this should not happen. So that is about taking care of security. Okay, and finally we have catalog management. Okay, so what is a catalog? Catalog is just the directory where we are storing the metadata. Okay, now in a distributed system we have a notion of a global catalog and a notion of a local catalog. Okay, so what is this? Let's come down to this figure. Okay, my global catalog is going to tell me what is located at P1, what is located at P2, what is located at P3, and so on and so forth. While my local catalog is going to tell me how the elements located at P1 are related to each other. Okay, it is going to contain information regarding database at P1 only, while my global catalogs contains information about all the databases and how they are stored. Okay, so since in a fragmentation concept, you know that upper half is stored at site 1. This kind of information is going to be present at global catalog. Okay, and my local catalog is going to tell me the interdependence or interrelation between the elements that it is storing. Okay, now let's understand the concept of fragmentation in a bit more detail. Okay, fragmentation. Okay, we've already seen what fragmentation is. Now let's understand horizontal and vertical fragmentation in some detail. First, I am going to start with horizontal fragmentation. The concept of horizontal fragmentation is we divide the tuples in some groups which have some logical meaning. Okay, so group the relation into subgroups having logical meaning. Okay, and distribute it to different sites and distribute. Okay, so what I can have here is, let's suppose I have a employee relation which is something like this. I have the employee relation which has employee ID, employee name. Okay, let's suppose it has the guy's age or the girl's age for that matter, his phone number, his address. Okay, what else we can have? The department in which he works. Okay, his email. Okay, so let's suppose these kind of information is what I am storing in my employee table. Okay, this is in continuation. So in a horizontal fragmentation, what I can do is I can distribute this employee table something like this. This is my network, right? This is my, let's suppose, site 1. This is my site 2. And this is my site 3. Okay, so what I can do, at site 1 I am going to say I am going to store the employee table where department name is equal to research. Okay, so all tuples or all employees which are in research department, the records of those employees are going to be stored at site 1. Similarly, here I can say department name is equal to, let's suppose, finance, and at site 3 I am going to store department name is equal to operations. Okay, so this is how I fragment my employee relation into 3 subgroups which have a logical meaning, right? This fragment says that these employees are working in research. Okay, there is a logic to it, and I distribute them over to 3 sites, site 1, site 2 and site 3. Okay, now this condition on the basis of which I do the fragmentation, okay, these conditions are known as guard conditions. Okay, I'm just going to write it down over here, guard conditions. Okay, so that was my horizontal fragmentations. Okay, so let's now look at complete horizontal fragmentation. Horizontal fragmentation. Let's suppose I have 3 fragments. Okay, department name is equal to D1, department name is equal to D2, and department name is equal to D3. I call this fragmentation complete if together the tuples of this fragment and tuples of this fragment and tuples of this fragment together form the entire relation. Okay, if this is true, then I call my fragmentation complete fragmentation. Okay, so how do we get back the whole relation from my fragments? I take the union of each fragment so that I can get back the whole relation. So whole relation is equal to fragment 1 union fragment 2 union fragment 3 until all the fragments are unioned. Okay, so now let's talk about vertical fragmentation. Okay, as I already told, here we keep some attributes at some locations. Okay, not all attributes are kept at one location, rather only some attributes are kept at a specific location. Each fragment contains some attributes of the entire relation. So I have my employee relation, so what I can do is I can keep my ID, I can keep my email and department name at one location, and at the other location I can keep my ID, name, age and phone number. Okay, just understand over here, in vertical fragmentation there has to be some common attributes between fragments. Okay, some common attributes between different fragments. Why do we need this? Because if you do not have a common attribute, then you won't be able to take the join. And if you are not able to take the join, then you would not be able to reconstruct the whole relation. Okay? Why do we need this? So that we can take join. And why do we need to take join? So that we can reconstruct the relation, right? So in my employee table, which was up above, as we have seen, what I can do is I can create two tables. One would be employee personal, that has personal details of the employees, and it is going to have his ID, his name, his phone number, his address, his age. Okay, that is one fragment. Okay, and the other fragment would be employee official, right? So in my employee official, I can have my ID. Let's use a different color over here. I can have my ID, I'll have the department name, and I'll have the email. Okay, the official email. So this is my next fragment. Okay, so this thing I can keep at site 1, and this I can keep at site 2. Therefore, I say my employee relation is vertically fragmented into two relations, employee personal and employee official. That was about vertical fragmentation, right? The guard conditions or the basis of fragmentation over here is mentioned with the help of project operator, right? I can say project ID, comma name, comma phone, comma address, comma age, from what? From employees. And what I'm going to get? I'm going to get my employee personal fragment. Okay. So now let's look at what is a complete vertical fragmentation. Okay, complete vertical fragmentation. Whenever we have fragments, each having list of attributes, let's suppose L1, L2, L3. Okay, these are my fragments F1, F2 and F3. F1 has attributes L1, F2 has attributes L2, and F3 has attribute L3. Then this fragmentation is complete if I have L1 union L2 union L3 is equal to my relation, that is the union of all these attributes list is equal to the entire attributes of the relation itself. Okay, so if my R is A comma B comma C, and let's suppose L is A comma B, L1, L2 is B comma C, and L3 is C comma A, then you can see that union of L1, L2 and L3 are or is A comma B comma C, which is my entire relation itself R. Okay. Next condition is the intersection of any two attribute lists should be equal to the primary key of the relation. Okay, so as you can see over here the intersection of employee personal and employee official is ID, which is the primary key. Okay, and I hope that union of these attributes L1 and L2, that is attributes of employee personal and employee official, is the relation itself. Okay, it is this relation. Hence I can say that this fragmentation is complete. Okay, now we can also have a mixed fragmentation, okay, or hybrid fragmentation if I combine the above two vertical and horizontal fragmentation. So what I can do is, let's suppose what I do is I have let's suppose a network, and this network I have site 1. Let's do it in a different color. I have site 1, I have site 2, let's call it as S1, S2, I have site 3, and I have site 4. So if I have to create a mixed fragmentation, then what I can do is, in site 4 I will store the entire personal details of all the employees. Okay, so what is my site 4? My site 4 is project ID, name, address, phone, and do we have some other personal detail? Name, phone, address, and age. Okay, age from employees, and keep this in S4. Okay, so at this moment I have created my vertical fragmentation. Okay, now what we are going to do is, I am going to distribute the official details based on departments. Okay, so at S3 what I am going to do, I am going to project ID, email, and department name, where department name is equal to research. Okay, from what? From employee, right? At S2 I am going to do the same, okay, but I am going to store what? I am going to store the details of finance department. Okay, so here goes my finance, and at S1 what I am going to do, I am going to store the official details regarding operations department. Okay, so I am going to have, let's call it as OP. So this is my hybrid or mixed fragmentation. Okay, so here I have vertical as well as horizontal fragmentation. Some attributes are stored at some places and some tuples are stored at some other places. Okay, so if you can think of it this way, here, or rather just use a different color, between this part and this part I have a vertical fragmentation, right? Because here I have all the rows with these attributes, and in this part, that is S1, S2 and S3, I have all the rows with these attribute lists, right? And similarly I have horizontal fragmentation between these guys, S1, S2 and S3. Okay, so here I have horizontal fragmentation, and since I am having a combination of all these over here, I call this a mixed or hybrid fragmentation scheme. Okay, so the information regarding what fragments contains what type of attributes or tuples is stored in something what we call a fragmentation schema. Okay. So fragmentation schema determines how a relation is fragmented. So let's suppose in my schema what I can have is, I would have values like, let's suppose the fragment at S1, I am going to tell that it has employee table in which attributes are, what are the attributes at S1? ID, email and department name. ID, email and department name. Okay. And it has the guard condition as, guard condition, what is the guard condition? My guard condition over here is department name is equal to operation. Okay, so my department name is equal to operation. So this is telling me about vertical fragmentation, right? The attributes that it contains, and this is telling me about horizontal fragmentation, that is the tuple that it contains, right? So that is how a schema is constructed for a particular table. From my fragmentation schema, I get to know where a particular tuple could be. So if I am searching for let's suppose the name of the person working in operations, then I know that name I won't get in S1. Why? Because S1 only has ID, email and department name. So I would have to go to where? S4. My fragmentation schema would be having an entry which is saying that S4 has attribute list as ID, name, address, phone number and age. So since I get to know it has name and there is no guard condition over it, okay, so I can go to S4 and get my result. So that was about my fragmentation schema. Now let's look at allocation. What is allocation? Allocation is assigning a fragment to a location. Okay, so let's suppose I call this fragment F1, this fragment F2, this fragment F3, this fragment F4. Then I say F1 is allocated to S1. Similarly, F2 is allocated to S2 and so on. And what is an allocation schema? Allocation schema determines where a particular fragment resides. Okay, it has information on where fragments are located. Okay, so that was about my allocation schema.